Hello, let's see these questions for Act 2 Chemistry about the periodic trends. This final revision 15 MCQ questions on 60 slides. Let's start the revision. First question, which of the following properties increases as you move from left to right across a period? Is it atomic radius, electronegativity, metallic character, or electron shielding? The options were atomic radius or electronegativity, metallic character, and electron shielding. The correct answer is electronegativity. What is the explanation behind that? B is correct because as you move left to right across a period, the number of protons increases while electrons are added to the same energy level. So let's say we are comparing carbon or oxygen or nitrogen. I'll find that the number of electrons, there is carbon first and then nitrogen and then oxygen. I'll find that across a period, the number of protons increases, 6 protons, 7 protons, 8 protons. While this is the same energy level, carbon has 2 electrons in first, 4 in second, nitrogen in second, and oxygen in second. So it is still the same second energy level. This stronger nuclear charge, because the number of protons increase, pulls the electron closer, makes the atom more attractive to the electrons. This is called higher electronegativity. The atomic radius going left to right, not increase. So you cannot say the answer is atomic radius. Characters of the metals, metallic character decrease going left to right, and shielding remains relatively constant across the period. So you cannot say it increases or decreases. So the concept summary is that electronegativity trends increases left to right across the period. It decreases from top to bottom down the group. Fluorine is the most electronegative element and francium is the least electronegative element. Why? More protons equal to stronger pull on bonding electrons. You can make a screenshot for this for quick revision if you wish. Let's see question number 2. Which element has the largest atomic radius? Is it sodium or magnesium or aluminum or silicon? The correct answer is sodium. But why is the correct answer the sodium? Let's see the explanation. Sodium, magnesium, aluminum, and silicon are all in the same period. They are all in period number 3. Group 1, group 2, group 3, group 4. Moving left to right, the atomic radius decreases. So the sodium is bigger than aluminum than silicon. This is because increasing the nuclear charge, the number of protons increase, pulls the electrons closer to the nucleus. Sodium is the furthest left, so it has the largest atomic radius. So the order is sodium is bigger than magnesium, bigger than aluminum, bigger than silicon. Let's memorize this as the atomic radius decreases from left to right, increases top to bottom. Across the period, more protons plus stronger pull equal to smaller radius. Down the group, more shells equal to larger radius. Largest atomic radius is the francium and the smallest is helium. Let's move to the next question. Question number 3. The first ionization energy of magnesium is higher than magnesium. Why is that? We know magnesium is here and sodium is here. So first ionization energy increases as you go from left to right. So, but what is the reason? Is it because magnesium has more electron shells, or it has greater nuclear charge with similar shielding, or it has weaker nuclear attraction, or it has more protons? The answer is that it has greater nuclear charge with similar shielding. That's the correct answer. And we need to know that magnesium has 12 protons and sodium has 11 protons. Both are in period 3. So they have the same number of electron shells and similar shielding. However, magnesium has one more proton, creating a stronger nuclear charge. This stronger nuclear charge attraction means more energy is required to remove an electron. That's why the higher ionization energy. Next, we have to memorize that the ionization energy trend is that it increases from left to right and decreases from top to bottom. Higher nuclear charge cause it be harder to remove the electron. More shells as you go down makes it easier to remove the outer electron in addition to the shielding that will be added. The highest the highest ionization energy element is the fluorine, and helium is also high, but take care, helium is a noble gas. Lowest ionization energy is the francium. Next question is, which ion is larger than its parent atom? Sodium or magnesium or chlorine or aluminum? Let's try to imagine some ions, when you add electron or remove electron, the size will be different. So what is the answer? Answer is chloride. Cl minus is a chloride. It's larger than its parent atom. Let's see why is that. When the atom of chlorine gains electrons to form Cl minus, this is the chloride anion, they become larger. But why did they become larger? They become larger because one first electron repulsion increases. The number of electrons here become more than the number of electrons here in the Cl and the Cl minus. Cl minus is more. The same nuclear charge, the 17 protons, now attracts 18 electrons instead of 17, cause it to attract it less effectively. It's like one mother trying to attract her children. If she has more children, she will have more difficult time in trying to attract them. Cl minus has 18 electrons, but only 17 protons. So the cations of sodium, magnesium, aluminum are smaller than their parent atom because they lose electrons. So exactly the opposite happens. They are all cations, and always in the cation the size is smaller, not bigger, but in the anion the size becomes bigger. Let's see the next question. But before it, we will remember that the cations are smaller than the parent atom. They lose electrons, same proton pull fewer electron closer. The ion is bigger than its parent atom. Gain electrons means more electron repulsion and the same protons. So the same number of protons attracts more electrons, which is more difficult. That's why the attraction is less and the size differs. Example, sodium is 186 picometer. This is the unit for measurement of such a tiny size compared to sodium, which is 102 picometer, that's smaller, while the chloride is 181 compared to its chlorine atom, which is 99 picometer. In the next question, we ask, down a group in the periodic table, ionization energy generally decreases. But why is that? Is it because the atomic radius decreases, the nuclear charge decreases, outer electrons are further from the nucleus and more shielded, or electronegativity increases? Let me give you a chance so you can answer this in 5 seconds. Down a group, the answer is correct. Outer electrons are further from the nucleus and more shielded. This causes it to have a higher ionization energy, because when you go down a group, each element has an additional electron shell or layer. This means the valence electrons are further away from the nucleus. The inner electrons provide more shielding, and both factors weaken the attraction between the nucleus and outer electrons, making them easier to remove. Lower ionization energy means easier to remove. So memorize the inner electrons shield outer electrons from the nuclear pool. The inner or the core electrons make it very difficult for the attraction to happen. This is the nucleus, and there is a lot of core electrons as you go down. So the electron is less attracted to the nucleus because there is repulsion happening from the core electrons. This makes it very difficult to be attracted. So as you go down, the attraction will become less and ionization energy becomes less. It's easier to remove. While down a group, the shielding increases. Across the period, the shielding is the same because it's the same number of layers. Remember that no change in the period. So easier to remove outer electrons going down and harder to remove outer electrons going right means ionization energy increases. Next question. Which of the following elements has the highest electron affinity? The most negative value is the electron that can easily attract an electron to itself. The atom that can easily attract an electron to itself. We have fluorine, chlorine, bromine, and iodine. What is the answer? Again, I'll give you 5 seconds. to test yourself. Which of these elements has the highest electron affinity? It's of course chlorine. Chlorine is the easiest one to accept an electron because while electron affinity generally increases going to a group, the chlorine has a higher electron affinity than the fluorine. This is because fluorine's small size causes significant electron-electron repulsion when an extra electron is added. Chlorine is the sweet spot, small enough for strong attraction but large enough to accommodate the extra electron. So let's say as you go up a group, it should increase. So the fluorine should have higher affinity, but take care. The chlorine has higher affinity than the fluorine because the fluorine has a small size, so it's not able to attract more electrons, while the chlorine can do this easily. So memorize, generally the electron affinity increases from left to right and increases bottom to top. Exception is the chlorine and fluorine. Very important to understand the exception. Why? Because fluorine is too small. If you add extra electrons, this will cause severe repulsion with the electrons already available in the atom. So the most negative is the chlorine. Halogens have highest electron affinity, want one more electron in them. Next question, arrange these elements in order of increasing atomic radius: phosphorus, sulfur, chlorine, and argon. Have a look inside the periodic table and have a chance to answer this. Yes, your answer was correct. The argon is the smallest radius, followed by the chlorine, then the sulfur, and the phosphorus. But why is that? All four elements are in the period 3. So what is the difference? The difference is that the argon is on the right, phosphorus is in group 5, sulfur is in group 6, and chlorine in group 7. We know that the atomic radius decreases from left to right across the period due to increasing the nuclear charge. The phosphorus is the most left, so that is the biggest one, and argon is the most right, that's the smallest one. So order is argon is smaller than chlorine, which is smaller than sulfur, which is smaller than phosphorus. So always remember, as in the next slide, the period 3 atomic radii, sodium is 186 largest, while argon is the smallest. The pattern is steady decrease from left to right. Next question. Which statement about metallic character is correct? It increases across the period. So as you go from left to right, is it possible that you increase the metallic character while you are going towards the nonmetals? I'm giving you a hint. Does it increase down the group? Does nonmetals have higher metallic character, or it increases with increasing ionization energy? Remember, you should always put an answer in the exam. Don't leave any question empty in the MCQ. Now, I hope you found your answer. Yes, the answer is that it increases down the group. Why is that? Metallic character increases down a group because outer electrons are further from the nucleus and more easily lost. The metal loses electrons easily. It decreases across a period as elements become more likely to gain electrons. Why is that? It's bigger, right? Low ionization energy, higher metallic character can easily remove an electron because the electron is very far. It's lower ionization energy. I can remove the electron easily from the nucleus. It's very far, and there is shielding. Ionization energy is low, so you can easily remove the electron. That makes it a metal, right? Metals lose electrons. So the metallic character increases from top to bottom and decreases from left to right. You are going towards the nonmetals. Remember, this is the periodic table. You are going towards nonmetals, so of course the character decreases. So the metals lose electrons easily, low ionization energy. Non-metals gain electron easily, higher electron affinity. Remember this, very important. Most metallic is the francium and the least metallic is the fluorine. Metalloids diagonal, that's a boron, silicon, germanium, arsenic, and so on. They are between the metals and non-metals, remember? What is my next question? Number 9. The effective nuclear charge experienced by valence electrons. What is the meaning of the effective nuclear charge? And does it decrease across the period? Is equal to the number of protons, increases across the period, remains constant across the period.